It took me like 7 hours.
7 hours?
Yeah. No, it took me like.
Okay, so if you look at number 1 here, that's exactly like the problems that you had. Like I told you, how many problems did you guys skip? 12? I'm only gonna give you like 4, I think. So let's do a difficult one. So knowing your algebra skills, let's do D. Y equals 9/2, and you know the answer is going to be nice, right? Because that's the way I make them. 9/2 sine inverse x over 3 minus x over 2 root 9 minus x squared. Okay, compute the derivative and then simplify. So I'm guessing the most I'll take off on any one problem will be 5 points. So 2 points for the derivative, 3 points for the simplifying. Okay, first term. Okay, that's a constant. So anytime you have a constant, throw it on the side like an unwanted pet. Yep. And then how do I take the derivative of this?
1 over
Sine inverse box.
1 over root.
1 over root
1 minus box squared.
box squared. And then the most important part, because if you don't do this, that's a fatal error. Times the derivative of the box. 1/3. Yeah,
Wait, where is that?
that's D, 1D.
I mean, is that in the drive?
Huh?
Is that like thing in the drive?
No,
Wait.
these are just extra problems I found on my computer.
Oh.
Did you send it?
Oh, yeah.
Take a picture.
No, I gave you guys the practice test.
But we want to practice more.
You won't.
Yeah, we are. We're practicing right now.
We're doing it here, bro.
Oh, but we're not going to do all of them now.
Okay, take a picture then. See, this is like an actual test that I gave. Every year, the format of the test is the same. It's a matter.
No, Joey, take yourself.
Really? Wait, how about just one person take a picture and then you like share it like in
Because we're
the,
not that smart. We're not that smart.
take a picture of his screen.
Bro, just here.
So dumb. Who wants this one? Picture.
Oh, but wait, then don't you want to take a picture of the answers then?
Yes.
Okay, whatever. So you want me? Okay, you know what? I can just send it to you if you really want.
I have a whole lot.
A lot of.
Yeah, but, oh gosh. Can we just do this?
Yeah, let's just do this first.
Minus, well, I'm not gonna send it now. It's gonna be like next period if I do it.
1/2.
Okay, wait. Let me call on people here. We gotta make sure we know it. Lee 1.
Got it.
Lee 1.
Justin,
Justin or
No.
Connor.
Lee 1, Lee 2, come on. Get with it.
One's
Alphabetical order, right?
Minus 1/2 times the square root of 9 minus x squared times
Mm-hmm.
oh wait,
Mhm.
plus
What?
minus this. It should be.
Okay, look, it's like this, and then you gotta use product rule because it's a product, right? Okay, so you meant parentheses then. Yeah, that's what I thought.
plus 1/2 of wait, 1/2 of negative x.
Leave the first one.
Oh, the-
See, you put the minus on the side, see?
oh,
Just worry about what's inside here then.
The first one.
Oh, the quiz I put.
X over
x over half
X over half. Oh, X over 2.
times x over 2
X over 2.
times no 1/2 negative x one.
You mean 9 minus
minus
X
x squared.
to the, oh, your voice changing.
Eli.
Hey, only the person I call on is gonna answer here. To the,
To the negative half times negative 2x.
that That is correct.
Bingo.
See, you got 2 points in the bag.
You.
Let's go.
Look, if it's a product, you use the product rule. Derivative of the first, leave the second one alone. Leave the first one alone, derivative of the second. And how do you take, this is like to the 1/2 power, right? How do you take the derivative of box to the 1/2? 1/2 box to the -1/2 times the derivative of box. Okay, but now we gotta simplify this. So this 3 cancels into 9 here, 3 times, so you get 3/2. Let's go, 3/2, radical. Now, what do I do with this? How do you add or subtract fractions?
Common.
Least common denominator, so 9 minus x squared. But the 9 will come out of the radical as a
3.
3, so it's like this then, yeah? Okay. And then of course, when you divide by a fraction, that's like multiplying by the reciprocal, right?
Yes.
So this 3 goes up here and it's a 9.
There you go.
Okay. Minus root 9 minus x squared over 2. And don't forget, this minus sign got to be distributed, so what is it going to be?
Minus.
Say what, girlfriend? Because look, there's a minus here.
Plus.
Plus.
X.
Okay, this 2 cancels that 2.
X squared.
So x squared over
Root.
2 root 9 minus x squared. See, look, after the first step, it's just algebra. How come algebra is so difficult for us?
We don't know why.
It just is, Mr. Park. Okay, now how do you add these 3 fractions? You make the least common denominator, which is
2 root 9x minus 9 minus x squared.
There you go.
okay, what goes on the top? 9. This one you need to multiply top and bottom by root 9 minus x squared, so you're just going to get 9 minus x squared, right?
Yes.
And then plus x squared.
2x plus x squared.
So what's left?
2x squared.
2x squared over 2. 9 minus x squared. 2's cancel out. Final answer, survey says. X squared over root 9 minus x squared. And that's a pretty darn nice answer. Boom! See how I make my answers come out nice? So really, if I send you 2 of these pages, you can do them both?
No.
I doubt it.
No.
That's a lot to do, you know.
Very good.
Okay, let's do one more.
I'm not doing that.
Oh, I like A. Let's do 1A. 1A. I'm picking the ones that have involved algebra, that's why. Y equals secant inverse x. Gosh, I can't read from that one. Minus natural log x plus root x squared minus 1. And then I give a restriction, x is greater than 1, and you guys know why that is there, right?
Sure.
Because we're AB, we don't have to worry about the absolute
Yeah.
value.
There's an X in front of every secant.
Oh yeah, right there, see?
Oh.
See? All right, whose turn is it?
No.
G2.
Yes, sir.
Over secant x plus x over x and 1 over times x over 1 over x times root x squared minus 1
How come there's no absolute value?
because it's greater than 1.
Very good, because of that restriction, you don't need the absolute value. Otherwise, it's very difficult to simplify. Okay, good. Minus, and then who's got the derivative of this? Who's got the derivative of this?
It's one of the boxes. It's just one of
Hinderlighter.
Um,
One of the boxes, variable. Yeah. All the same.
negative 1 over root
sound like a man.
Root 1 over.
The derivative of natural log box is 1 over box times derivative of box. Okay, go.
Oh, x. Wait, aren't we just doing secant inverse x?
No, we finished that one. We're on this one now.
Oh, I see. Wait, I'm so
No,
confused.
no. Okay, just look at
What are we
this.
doing?
We're just doing this. Natural log box.
Oh, sorry. 1 over x plus, x squared minus 1 times, 1 plus half parentheses x squared minus 1 to the negative half times 2x.
There you go. So see, I know. I've been teaching this for years and years and years. You guys can do derivatives. Now, can you do algebra?
Who knows?
That's the problem. Okay, so we got secant inverse x plus, over here the x's cancel out. So you get 1 over root x squared minus 1 minus, I'm trying to keep it on this side of the board because that's all we can fit on the video. Now what the heck am I going to do with this? 1 over x, this is so beautiful, this might bring tears to your eyes, so you guys might want to get some Kleenex or something. Oh, for real, sometimes you do math and it's so beautiful you just want to start crying, yeah?
Yeah, definitely.
Or how about it's so difficult you just want to start crying? Okay, what do I do? And like I told you, change it to radicals after you take the derivative. So 1 plus, the 2's cancel out, so you get x over root x squared minus 1. Okay, that's perfect. That's right. Anytime you see fractions added together, you gotta make a least common denominator. So secant inverse x plus 1 over root x squared minus 1 minus 1 over x plus root x squared minus 1, and then you make a least common denominator here. What goes on the top?
Oh, wow.
What goes on the top? On the top, bro.
X squared.
Root x squared minus 1 plus x. Do you guys see it now? Yeah, this cancels that.
What are the odds?
And then, so this is what you have left. Although some of you don't even need to write it because you can see it, yeah? How can I see you get tears in my eyes?
Oh, it
So beautiful.
Oh my God, let's do that. That's it. I can really do this.
You know how long it takes me to write these problems just for you guys? I'm telling you, I don't think there's a teacher in the whole world. No, there might be a few in Korea or China. But I don't think there's any teacher in the United States that writes problems like that for the students, you know.
Thank you. Thank you.
You don't see it in any book. The book gives you these like easy Mickey Mouse problems.
Yeah.
I have a question. How did you get from this like fraction and then move it to
Okay, least common, so it's like this then, right?
Uh-huh.
Right? But the 9, so this is, what do we have up here? We have 3, yeah, okay, here. So, this 9 comes out of the radical as a 3. Right, isn't the square root of, okay, here, like this. So when you have square root of a fraction, it's like square root of this over square root of that, right? Okay, but square root of 9 is just 3.
So 2/3.
And then when you divide by 2/3, that's like multiplying by 3/2. So then that's why this becomes a 9 like that. See, that's always the part that gets students messed up. Algebra. I'll tell you right now, there's no way you'll get a problem this difficult on the AP exam. But we train above the bar, like I told you. Anyway, I don't think I'm going to give you a problem that difficult on the test. However, there's other problems, like the difficulty of the ones on the test would be like, I would say, B, C, and E, like that. Okay, let's do another one. Oh, no. Okay, let's go to number 5 then.
Henry.
Wasn't that fun? That was pretty fun, huh?
Yeah, of course it was.
I know.
Put it over
And I'm not gonna, oh, the next page got a crazy one. I don't even dare do it anymore.
Let's do it.
there. No.
No, I don't think you guys can handle.
Waste time.
No, it's not waste time, but then,
We AB.
like, we used to do it before. Okay, we're doing number 5, x squared e to the negative 2x. Okay, I forgot the question already. When is the first,
Greater than 0.
second derivative or first derivative? First derivative is weak. Okay, anyway. When is the first derivative greater than 0? So what you need to do is compute the first derivative, and then how do you do inequalities?
Number line.
You make a number line, but then you gotta factor it, that's the thing. Alrighty then. First derivative, Henry.
Oh, 2x times e to the negative 2x plus x squared times e to the negative 2x times negative 2.
See, you guys get the derivative, so don't worry about that. Okay, so we used the product rule perfectly. Oh, by the way, did I tell you that there's no semester exam in this class?
Yes.
You know why there's no semester exam?
We AB.
Because we're AB.
No.
No, and even BC, they don't have a, no, that's because our calculus program is so strong, we don't need semester exam.
Ah.
Semester exams are for babies.
Let's put all the ticket.
I don't know.
Babies.
Anyway, so now what we need to do is factor it and make a number line. Okay, what can be factored out?
2x.
2,
And I X.
x, and e to the negative 2x. Okay, what's left?
Everything else.
1 plus
1, what?
Minus X.
Minus
X.
x.
I can zero.
Oh, see, this was an easy one. See, second derivative would have been more interesting, yeah, because then you got to use the product rule for 3 things.
We're good.
Yeah. All right, make a number line. What goes on, what makes that 0?
0.
0.
What makes that 0?
1.
1.
1. What makes this 0?
Nothing.
Nothing. Remember I told you e to the gorilla is always positive. So basically it doesn't contribute at all to the number line. So it's like not even there, basically. Okay, think of a number bigger than 1. 2, plug it in. 2 times positive times 1 minus 2 is negative, right? So what is positive times positive times positive times negative?
Negative.
Negative, and how do I know they're gonna alternate? Because both of these have odd powers. And if you don't trust yourself, just plug in like 1/2 here and plug in negative 1 there. Anyway, I forgot the problem already. Is it greater or less than 0?
Greater.
It says greater than, so we want the plus sign. So the answer should be between 0 and 1. Pretty easy, huh? The hardest part is you gotta factor it so you can make a number line. Next chapter, you're just making number lines like the whole chapter. That's what's happening. You gotta get good at that. Okay, we gotta do number 6. Like I told you, this is on the AP exam multiple choice every year, and that's why it's gonna be on the test. The only thing, it's the same problem you got on your worksheet, of just putting different functions there. Gosh, I can't even read that. X squared plus bx. X squared plus bx, and x is greater than 1. Find the values of a and b so that f will be continuous and differentiable at x equal 1. Actually, you don't need the word continuous because differentiable means continuous and smooth. However, I don't know, but the AP exam, they always use those words, so that's why you do it. Okay, so what's the first thing I should write down?
Plug in.
Okay, first of all, how do you make sure that this function will be continuous at x equal 1? If you plug in 1 here and 1 there,
So A plus B.
they gotta be equal, right? So that they actually meet and touch. So what do I write to get a point?
A plus B.
2 equal
A plus
A plus B. Ding! 1 point. Okay, but now to guarantee that it's gonna be smooth, the left-hand slope gotta equal to the right-hand slope, so that means you gotta compute derivatives. Okay, so x is greater than 1, x is less than or equal to 1. I'll do this one, that's easy. Okay, but this is the one that we learned this chapter. Tyler, what's the derivative of 2 to the x?
2 to the x times ln2 times 1.
There you go. Because some of you on the last quiz, you guys are trying to natural log both sides, but this is the a to the u one. You gotta memorize the guarantee, because that's gonna come up at least once on the test. Okay, so the derivative tells you the slope. So if you plug in 1 here, that would be the left-hand slope. If you plug in 1 there, that's the right-hand slope, and then they gotta be equal. So plug in 1 into each one, and you get 2 ln 2 equal 2a plus b. Whee! You got another point. In fact, I might give you 2 points for that one. 'Cause okay, now you gotta use algebra to solve for a and b. Now, if I were me, I would line them up like this. Okay, just put down there. So if I want to get rid of the b,
-1.
you just subtract. So subtract. 2 ln 2 minus 2 equal a. 1 point. And then once you get that, how do you figure out b? Substitute it in, or do you want to do addition, subtraction? I don't care what you do.
Substitute.
Substitute. So if I plug this in for a there, you get 2 equal 2 ln 2 minus 2 plus b. So therefore b equals,
-2 ln 2
say what? Oh, negative 2 ln 2
plus 4.
plus 4. Oh, I thought you were going to do the 4 first because it just looks nicer that way. Well, that's okay. Can you repeat this problem? Yeah. Been doing it right all this time.
Because you have to think about it.
Okay, number 7. Number 7. I forget, I was just looking at it and I forgot already. F of x is equal to cosine x to the x power. Compute the derivative. Which rule do I use here?
Natural law.
Well, you can't use any of the derivative rules. You gotta use logarithmic differentiation. If this and this, if neither of them is a constant, that's the only way to do it. So what you might want to do is change the f of x to a y. You guys did it on the quiz, right? Natural log both sides. No, some of you, never mind. Natural log both sides. And why do we natural log it? So you can put the power
On the front.
in the front, and then now it's more manageable. So now you do implicit differentiation. Who's got this one? Aduha.
1 over y times y prime. Sorry, ln cosine x plus x 1 over cosine x negative sine x.
Yup, I knew you could do it.
2 points still.
You guys don't remember that from the movie? I knew you could do it. No, you guys forgot to line up against the wall like a snake.
Oh, yeah.
I didn't get that.
Here, let me.
He shook his hand.
No, we're actually going to do that, when we prepare for the AP exam.
What?
We do drills.
Wait, why?
Because that's how we beat everybody else. That's why.
I'm standing in a line.
No, you
No,
said
no.
in a line, he asked you problems.
No.
Oh,
Yeah, in the movie, they stand against the wall in the line. In my class, you just sit in your seat and answer the question.
Oh, okay.
Oh.
Like, do you remember? Okay, he went up, Pancho was the girl, right?
Yeah.
She was first, and he goes, what is the domain of f of x equal 2 ln x minus 1? And the girl said, x is greater than -1. No, to the end of the line. And then Pancho came up and said, x is greater than 1. That is correct. I knew you could do it.
Yeah.
Do I have to repeat every
Well,
single?
that's good, that's good.
He's the.
Because remember, when you have a logarithm, this thing has to be greater than 0. Solve for x, x is greater than 1. Okay, anyway, Okay, back to this problem. Multiply both sides by y, so y times natural log cosine x plus, no, that's a minus. And then what is sine over cosine? Tangent. And I will accept this as your answer. If you want to plug in the original one for y, you can, but once you do that, good enough. Good enough. So when do you do this? When neither this nor this is a constant. I want to make sure everybody knows. But what happens when you have this? What if you had y equal 5 to the secant x? We have a rule for that. This is the a to the u rule. Now, yes, you can natural log both sides if you forget the rule, and it'll come out to the same thing, but I would rather have you guys just know the rule. Okay, so what is the derivative for this one? What do we got here? Ishiko!
5 secant x times natural log 5 times secant x tan x.
Oh, look at that. See, you guys are like 4 for 4 on derivatives. But then 0 for 4 on the algebra. That's okay, next one. Okay, now let's scroll already. Let's scroll to the next one. I mean, these are the ones you guys know how to do these. I don't think we even have to discuss them.
How do you know what to stop? Like a simplify.
When I'm done. Look, what is the rule for a to the u? A to the u times natural log a times the derivative of u.
Yeah.
So what is the derivative of secant x?
But no, like how do you know like what if there's some crazy way that can be simplified?
Oh, then you simplify.
Like how do we know that though?
Bro, Eli.
Okay. Okay, I'll tell you what, this problem on the test, I'll probably make you compute it at a value of x. I probably would ask you, okay, what is the slope of the tangent line? Oh wait, I gotta go to it. What is the slope of the tangent line at x equal pi over 3?
Plug it in.
So then, okay, you take the derivative, now plug in the number. Which is another hurdle, air trig values. What is the secant of pi over 3? Oh, very good. Oh. So, 2. And what is tangent pi over 3? Root 3 over 2? Root 3. Okay, but then no, that's 25. Final answer, survey says 50 root 3 natural log 5. Ka-ching! Okay, you gotta know when you can simplify it. Like that one, there's nothing you can do to simplify it. Is that what you meant?
Like what if I know sometimes we have that one.
Well, like sine over cosine tangent,
Or
right?
how do you know like sometimes do we ever have to distribute the y or like plug it back in and distribute it?
No,
Okay.
no, I don't think so. I mean, if you can, if you
Wouldn't
want to.
sometimes maybe it might come out to a simpler number.
Maybe sometimes. No, I would say no. No. Okay, let me scroll to the next screen. No, I changed my mind. We're gonna do number of 3. What time is it?
1:39. Gosh. Yeah,
Y cubed plus y. Somebody just read it to me. Y cubed plus y equals
2 cosine x plus 2.
2 cosine x plus 2?
Like parentheses around x.
Oh yeah. I didn't think I would put a plus 2 there, but there's probably a reason for that. It says compute the value of the second derivative at the point 2 comma, no, pi over 2 comma 1. So what we gotta do is compute the second derivative and then plug in this point. So how do you think I'm gonna compute the second derivative here? Implicit differentiation. Oroka, first up.
2y.
Bleh. No, to the end of the line.
That's not a 2.
This is
Oh,
a,
sorry.
that's a 3.
I can't see 3y squared times y prime plus y prime equals 2.
Okay,
Wait, is it not a 2?
no, it isn't.
The final.
Oh, negative sine x plus 0.
Okay, correct. There you go, see? 5 for 5 on the derivatives. Okay, well now we gotta solve for y prime, but look, they're all on one side already, so we just factor it out. And then you divide. Okay, now we gotta compute the second derivative. So taking the derivative of both sides, doing implicit differentiation again. How do I do this one?
Low D high.
Yeah, that's called the quotient rule.
Oh.
Temper,
Yes.
quotient rule lookatize it.
3y squared plus 1. Negative cosine, negative 2 cosine minus 6. Right? Oh, okay, fine. Negative 2 is beside that.
Oh, you do yours differently.
I just throw the derivative first because
Oh, so you go low D high minus D low,
High.
D low high, all over denominator squared we fly it. That's what you do. Okay, I mean, no. Okay, you can do whatever you want, but as long as it's correct.
6y,
Wait, I wanna know who taught you that.
not you.
Okay, good. 6,
6y plus 0.
6y, oh, what's the derivative of box squared?
Oh, y, y to the prime.
Y prime.
Yes.
Okay, all over.
3y squared plus 1.
Yeah.
Okay, that is correct.
Yay.
Okay, and then all you have to do is plug in the point. Oh, what do I do for the y prime?
Like the order.
Yeah, you gotta do this. This is y prime. So what you gotta do is you gotta plug the number into here and then take that number and plug it into there. So this is a lot of plugging in, but come on. Cosine of pi over 2 is 0. So if this is 0, this whole thing gets wiped out, right?
Yeah.
Sine of pi over 2 is 1, so I think you guys can plug in the numbers. I'm pretty sure you can.
Chad.
So wait, if I didn't teach you that, who taught you that?
Myself. No, because I say it correctly in my head, but I'd rather do the derivative first because it's not straightforward.
Okay. Okay, now I'm gonna scroll to the next one. We got 15 minutes left. Okay, let's just do a couple more. I'm getting tired already. You guys are wearing me down.
Who's that one?
Oh, okay, here. Number 5. Let's do number 5.
I'm so excited for my heroin presentation.
We did one like this last week. I don't know if you guys remember. Compute the limit as h approaches 0
Wait, let me just see.
of 10.
Oh, there's another one.
Gosh, I can't even see that. Is that a square or a cube? It's a square. Square pi over 3 plus h minus tangent squared pi over 3 all over h. Okay, what do I do when I see this problem? A, skip to the next problem? No, who said that? You know what?
Transfer.
No way, this is review. No way. You guys are like a blind man in a dark room looking for a black cat that isn't there. No way. It's like a stab in the back. No way.
Good job, Eli.
Watch that
Thank
movie.
you, thank you. You guys remember that from the movie?
Yes.
How can you say no? Okay, who did I call on that?
Topper was last.
Toad. What do I do when I see this problem?
Just take 10 square pi over 3 and then differentiate it.
Okay, close. Okay, she said look at this and then take the derivative of it.
Yeah.
Okay, but if you take the derivative of this, you get 0 because it's a number, right?
Oh, you put that as x first.
Okay, think of this as x, take the derivative, and then plug in pi over 3. Yes, this is the definition of the derivative. This is equal to f prime of pi over 3. Again, means take the derivative first and then plug in pi over 3. Okay, so Toll, what is the derivative of tangent squared x?
2 tangent x, 1 over 1 plus.
Oh!
It's regular tangent.
Yeah, don't get tangent confused with tan inverse.
Sorry, secant square x.
Yep, there you go. And then probably the hardest part for some of you plugging in pi over 3, yeah. We just did it though. Didn't we just do it back here? Yeah. What is tangent of pi over 3? Root 3. What is secant of pi over 3? 2. Okay, so what is that? 8 root 3.
Yeah.
Ka-ching! So the main thing is you recognize this as the definition of the derivative. Anytime you see limit as h approaches 0, this is AB. I'm not going to try and trick you like BC. If you see limit h approaches 0, it is the definition of the derivative. Okay, let's do one more and go home.
Yeah.
Which one is going to help you the most on the test? I mean, all of these are going to be on the test.
No, that's okay. My eyesight is.
Your eyesight.
My eyesight's not good.
Let's do the.
Your eyesight will unblur.
What? There's no word problems on this list.
The blue,
Oh,
number
no.
Number 8 because it has words. Are you serious?
in the last one.
Did I tell you about my dream last
No,
night?
no.
Did I tell you about my dream last night? No.
Oh,
No.
So, I was at a
No,
pier.
no. If I'm not going over it, oh, I can't say that because never mind.
I was
It's
at
not
a
hard.
pier and there's a panda in the water and I took a selfie with the panda.
Okay. Do you guys want to do this problem that we haven't done for like over 10 years? Look at C. Okay. This problem is not going to be on the test, but we're just going to do it for funsies.
Oh my god, I should ask her. I think.
So when I teach BC calculus, we always do this
It
problem.
was like a person wearing a panda mask.
What does it say? Sine to the 4th 2x plus cosine to the 4th 2x. Compute the derivative, but then the hardest part is the simplifying. If you don't know your trig identities, then okay. I'm pretty sure you guys can do this. So whenever you have a trig function to a power, write it like that. So the derivative going to be easy, right?
Of course.
Tom, derivative. Box to the 4th.
4 sine cube 2x. Or, no, sorry, cube 2x times 2.
Okay, no, wait. 4, so the derivative of box to the 4th is 4 box cubed times the derivative of the box.
Oh, times cosine 2x times 2
Okay, good. And then the next one?
plus 4 cosine 2x times negative sine 2x times 2.
Okay, but don't forget the cube, yeah?
Yes.
Okay, there you go. That's correct. Okay, here's the best part, now the simplifying. What can be factored out? Rhymes with mate. 8. Sine 2x, cosine 2x, and then what's left? Sine squared 2x minus. Okay, that's correct. Okay, but you gotta simplify it. And you almost somebody. You almost somebody.
But it's not.
No, it is, but you gotta do something. Don't say 1. It's not 1. If that was a plus sign, it would be a 1. But it's not a plus sign. Oh, there you go.
Yeah. Because it's
Okay, you see this minus sign, factor it out. Factor it out. And then you're going to get cosine squared theta minus sine squared theta. Cosine squared theta, here, I'll write it down. Cosine squared theta minus sine squared theta. Hey, that's somebody, huh? Cosine 2 theta.
Oh.
That's double angle. Okay, this is on the AP exam. Double angle, no half angles, but you gotta know double. So what is this? Like Tapper said, cosine.
Four.
Well, if this is theta, what is 2 theta?
4x.
4x. Okay, I'll give you 1 point for now. But then look, hey, you almost somebody.
2 sine.
Yeah, if there was a 2 there,
So take it off.
see, 2 sine theta, cosine theta, hey, you somebody. Isn't that sine 2 theta? Okay, look, so, can't I write the 8 as 4 times 2, so then, you somebody? Okay, so what is this then?
Sine 4.
That's sine, if this is theta, then 2 theta, 4x, times negative 4. But then, hey, you almost somebody, look, sine theta, cosine theta. Yeah, so then you change the 4 to 2 times 2, and then you go, hey, you somebody?
2 sine. Negative 2 times sine.
Yeah, wait a minute.
Sine.
Sine
8.
8x.
There you go. 2 more.
Boom! Isn't that neat?
No.
That's hard. If I was like, I'd be stuck at the 8 cosine x, 2x.
See, this is how, you guys don't know how lucky you are to be AP.
We know.
In BC, come on, this is just double angle identity and this is your 3rd year of trigonometry experience, right?
Mm-hmm. After the third one, I do stuff.
So who taught you regular trigonometry?
Cropsy. What's
See,
her name?
he's an expert in double angle
Hey,
identity.
what's her name? What's her name? What's her name?
Mrs. Cropsey? What?
Summer school. I took summer school.
Klein.
Miss Klein?
Yeah.
Mr. Sasaki?
No, I had this line.
I Klein.
I don't remember anything.
Soccer's good, I just don't remember.
Okay, whatever.
There's 5
Just, okay, you just listen to what I tell you. You get the 8, get the 5 on the AP exam,
That's all that matters.
then, see, you know what, it's good to get a 5 on the AP exam, because then when you go to college, then all, like, other people, they're gonna find out, and they're gonna come to you for help.
No, that's not.
No, because you're gonna be like you walking on campus, and they go, hey,
I'm gonna be the mayor.
Hey, I heard you good at math. Can you meet me for coffee and we can like go over some math problems? Oh, sure. That's how you get dates in college.
No, Dave.
No, I'm just using you for your
Very smart.
smarts. I
Oh.
take advantage of it.
Okay, you know what? I don't think I need to send this to you. Wait, do you want me to? Okay. You guys just, you guys just make more work for me, but you know what? I do it because I want to get you a 5.
Thank you.
Mama.
Thank you. Lose one.
You know who you guys should have? You guys know who, I'm trying to remember their names. Among and Morishige. I think they work on campus as proctors or something from last year, yeah. They'll tell you that I will go to any lengths besides cheating to get you a 5.
What does that mean?
Huh?
What does that mean?
To what extent?
That means I write extra. Oh, you know what somebody do you guys know, okay,
Well, then
do you guys have other AP courses?
yeah.
And then do you do the AP classroom thing?
Sometimes.
Okay, I'm gonna tell you right now, AP classroom is for babies. If you just
No, I
don't,
get 9 out of 20.
you know what somebody had a gall to ask last year, so Mr. And then, wait, and so in your other AP subjects, do they have like videos to watch like that?
Sometimes.
No.
Somebody had the gall to ask next year, so Mr. Park, should we go to AP classroom and watch the videos? They said, yeah, if you want to get a 2. Just
Yeah.
listen to me. I write my own problems. They're better than the AP problems. Just believe me. Hear me now and believe me later. But I don't want to get into that until we get to the 4th quarter. Just concentrate on learning calculus and then don't worry. Well, I guess you gotta worry. But... All right.
Go Wolves.
So yes, it's extra work for me, but I'll do it. So I'll send you both of them then.
Of course.
Sure. Thank you, Mr. Park.
Thank you.
Much appreciated.
So are you telling me that from now on 1 practice test is not enough?
It's been a week.
No, it's good for the homework.
It's been a weekend since I did.
Oh, that's because you did this homework last week Wednesday or something and it's gone.
Yeah.
Oh, I'll do it again then.
No.
No, but you like you were
Yeah, that'll work.
Whatever.
This is new, this is different.
Okay, let's go through our next class already.
So ready, you know,
Something like you won't be on the